Welcome everyone, and thanks for joining this webinar. And yeah, so in this workshop, I'm going to discuss ThinkGPT, which is a library to build agent projects with LLMs and to overcome limits in large language models. Um, my name is Aladdin, and I'm a machine learning engineer at Gina AI. And you can find here our Twitter handle, my personal Twitter handle, and Gina AI's Twitter. And in today's workshop, we will mostly discuss ThinkGPT and all of these agent techniques. So we're going to start with an overview and how to get started with the library and some interesting use cases that you can build with ThinkGPT. So I just wanted to introduce Gina AI quickly. So we're an AI startup founded back in 2020 with 60 global and international team members with 4 offices globally and $38 million in fundraising. And yeah, I guess let's start with ThinkGPT. So before discussing the library, I would like to give a quick overview of the large language models. As you all know, these are models that have interesting thinking capabilities, which the research community have confirmed, mostly reasoning and chain of thought prompting can showcase reasoning capabilities in large language models, and sometimes these reasoning capabilities can be showcased in a zero-shot manner. Large language models also can do in-context learning. With the paper, language models are few-shot learners with the GPT-3 model. And of course, you can use them to make decisions, write and fix code. But on the other side, there are a few limitations in the sense that they have limited knowledge. So you need to add long memory and external knowledge to these language models, and they have a limited context size. And with ThinkGPT, we aim to benefit from these advantages of large language models and try to overcome these limitations that we just discussed. And with the library, we try to add or introduce some features that can help you build LLM applications. Mostly, there's the long memory feature where you can inject external knowledge to the large language model. You store it in a vector database or in an in-memory store, and then you can use vector search and vector embeddings to use this external knowledge to infer real-time, to do real-time predictions with real-time data. And this feature is powered by the Docker Ray library from Gina AI. And then there's the self-refinement feature, which is like an interesting capability of large language models where you can ask a model to fix some code or fix its output based on previous criticism. And this is actually a feature that is used by popular open source projects especially for code generation, in the sense that you can have an agent that writes code and then runs it online, and then based on compile errors or runtime errors, it can fix itself and then continue improving the code in a self-healing manner. One of the features that is also necessary for large language models is knowledge compression, in the sense that you need to fit your knowledge in the limited context window. Of course, we need the inference, and I would also like to discuss natural language conditions in the sense that ThinkGPT offers a Pythonic API to allow you to make decisions using large language models. and you can actually use these conditions to make your application smarter rather than rely on heuristics to make decisions in your program. Of course, later you can build agents with the library, and the library itself is open source, and you can check it on this link. It's under Gina AI organization, and the name is ThinkGPT. So yeah, let's get started with the library, and I'm going to show you each of these features in action, and we will try to keep this workshop a little bit practical in the sense that we are going to have demos here and there and try to run code and see how it looks like. Of course, to install the library, just use pip, and so the basic usage is you import the library, you initialize the model, and then, of course, the first step is to inject knowledge for the large language model, and this under the hood will use Docker array and vector embedding to store this information. And then when you do predictions, you can write your prompt and then ask the LLM agent to remember information from its knowledge. So this is an example of basic usage, but then you can also do prediction with context from long memory, in the sense that you can inject knowledge base into your large language model, and then for example, here we discuss the Docker array library, which for which the V2 was released way after the GPT-3 cutoff, which was in 2021. So basically, we inject the Docker array V2 library documentation into the large language model. Then we ask the LLM to use the library to implement a schema with 2 fields, and the LLM should be able to use this new library that it did not see in its training corpus. Self-refinement is also one of the interesting techniques in large language models. So basically, you can give initial input to your large language model and a set of critics, and then ask the large language model to fix the initial input based on criticism from that you can grab from your environment, or from your compiler, or from your Python interpreter, or whatever. And then the large language model should able to pick up this error and then identify where was the wrong indentation and fix it. Natural language condition is one of my favorite features, because you can inject these conditions to make your large language model, to make your programs smarter, and not rely solely on heuristics to make decisions. So here you can actually introduce intelligence to your programs powered by LLMs. So there's the condition method that can return a Boolean based on whether a question can be replied with true or false. And the select method can select a set of options, select one or more options from a set of options. So here, for example, we ask the LLM which animal is the king of the jungle, and then it will select lion here. And in case you need to fit large content into the limited context size of the large language model, the library offers 2 methods for this. The first one is summarize, and the second is chunked summarize. So there's actually some difference between both methods. So the first one will let you compress knowledge using the large language model, given that the original content does not exceed the context limit of the large language model that you use. So if you are, I don't know, using GPT 3.5, I think you should not exceed 8,000 or 16,000 in the with the new model. And actually, you can specify the max tokens parameter here, or if you have much larger content, you can actually use the chunk summarize. So this relies on a technique where we split the content into chunks and then summarize each chunk, and then we concatenate each of them, and then do another round of summarization using the large language model. So this one, for this one, you don't have to respect the large language model context limit. And of course, you can also specify the target limit. So the target max tokens. And yeah, this max tokens will actually use the underlying large language model tokenizer. Yeah, so maybe I can show you quickly like one of these features. So let me quickly share my pie chart. So this is the Readme. So this is actually the Readme of the library, and here we have like a documentation of the basic functionalities. So yeah, maybe I can show you the self-refinement feature, and yeah, mostly what we need to do is like initialize the LLM object, and you can use it to perform refinement like this. So this is an example on how you can use LLM to perform self-healing on code generation. And by the way, this feature is powering popular open source projects like GPT Engineer or Gina AI's DevGPT or the Wolverine project. And so I can also show you, for example, LLM conditions like this. Yeah, and yeah, maybe we will see more examples with the use cases section. So let's go to use cases. So in the use cases section, I will show you how to teach new skills using long memory. So basically, you can inject information into the vector store of your agent, and then you can use vector search to perform prediction using up-to-date information. So in the first example, we give the large language model a set of observations regarding the Tunisian language, and the large language model is actually capable of extracting rules from these observations and storing them inside its long memory. And then when we ask it to do a specific translation task for the new language, for example, translate to Tunisian, I did not study. And then the large language model should be able to do the actual translation using the rules that it did extract from the observations. So this is like kind of shows the powerful reasoning and the in-context learning capabilities of large language models, and then how you can combine all of these techniques like abstraction and memorization to actually perform predictions for a new language. The other example, here we actually inject knowledge about different libraries, different Python libraries, and we actually ask ThinkGPT to use the ThinkGPT library to perform a certain task. And then ThinkGPT should be able to bring information about itself, and then use itself to write code and perform the task. So let's quickly see this in action. I do have the code snippet here in case anyone wants to try it out. Yeah, so this one. All right. So the ThinkGPT library is using LangChain under the hood, and by default we enable LangChain logs. But in case you do want these logs, you can actually like disable debugging with this flag. So yeah, let's check the results. So ThinkGPT now knows about itself and knows how to use itself using the documentation. And so here we memorize some information about Docker Array, and I believe this is kind of hallucination from the large language models. But then at the end, ThinkGPT knows that it needs to use the predict method and the remember method so that it can remember about Docker Array v2. Yeah. So okay, let's go to the next use cases. Another interesting use case that you can implement using ThinkGPT is the generative agents. So there was a recent paper released by Stanford researchers, interactive simulacra of agents. So this showcases emerging social behaviors in large language models, and actually researchers could implement agents that actually behave like humans, in the sense that they can observe other AI agents, save these observations in their internal memory, and then later replay their own memory and these observations to make further inferences about other agents and about the real world in general. And the paper showcases different thinking components or techniques, like performing self-reflection or replaying memory, or doing inference. And I will show you two examples on how you can build generative agents using ThinkGPT. The first one is replaying agent memory and inferring new observation. And the second one is how you can replay the agent memory, criticize and refine the knowledge in the memory. And so to give you an overview about the first use case, so replay agent memory and infer new observations, what we are going to do is insert some observations in the agent memory, and then replay some of these memories and infer new observations or deduce new rules based on the past. So actually, the library holds some examples. So the example is called replay and expand memory. And we can actually try it out using the terminal. But if you are curious about this demo's source code, so here the agent is storing some observations about Klaus Müller, and we will use the infer API and the remember API to deduce new observations. Then you can actually store these observations afterwards. And yeah, let's check what other observations the LLM can deduce. So first we had Klaus Müller is writing research paper and he's reading a book, and he's conversing with Aisha Khan about exercising. And the new thoughts that our agent extracted are: he is interested in various topics, and he's likely a well-rounded individual who enjoys both intellectual pursuits and physical activity. Okay, so these are two examples of what an agent can deduce based on past observations. Another use case here is replaying the agent memory, but with criticism and refinement of the knowledge memory. You can try this example using the terminal as well. And let's take a look at the source code. So actually we start with some memory, some observations in the agent memory, and they basically discuss some facts about Fibonacci. And actually, one of them is wrong. So here, so the agent learned about Fibonacci last week. Fibonacci starts with 0 and 1. Here, the agent used Fibonacci in a coding challenge. And okay, actually, the next number in the Fibonacci sequence is 1, and whatever afterwards. But then in our code, we will store these observations in the memory, and then we will start replaying the agent memory. And when we replay, we will perform self-criticism. So we will extract some critics for each observation, and then we will use natural language conditions to choose whether we want to refine, keep, or remove the observation from the memory. And in case we want to do a refinement, we will use the refine API to do that and add the new observation to the refined memory. And yeah, if we want to remove, we will just not add it to the refined memory. And if we want to keep it, then we will just append it as it is. In the end, we will print out the refined memory, and we will see what it looks like. So actually, this is a saved output. And so actually, the agent detects that this observation is actually wrong. So the second number in Fibonacci sequence is 2. And here it detects that actually the second number in the Fibonacci sequence is 1, because it starts 0, 1, 1. And yeah, then we end up with this observation in the new set of observations for the agent. Yeah, so here I put a link to this self-refinement technique. You can find it in the self-refine paper, iterative refinement with self-feedback, in the sense that an agent can actually generate feedback about itself and then perform self-refinement. And this is exactly what we implemented in this demo. I also invite you to check the generative agents paper. It's really an interesting paper, and it summarizes a different set of techniques that you can use to have an agent that can really think and behave like humans. And yeah, I try to implement some of these techniques in the library itself. Yeah, I think we try to cover most of the aspects of the library, and try to cover some interesting techniques that you can implement with large language models. And I hope that the library can be useful for you to build your LLM applications. If there are any questions, then feel free to reach out and to ask. You can also reach out to me on LinkedIn or on Twitter, and I will be happy to help.